Hello friends, welcome back to Learning Java Online. This is lecture second in this series. In the first lecture we discussed about why Java is so popular as a language as well as a technology. We also discussed regarding the most important feature of Java, which is the punchline of Java technology, that is Java is a platform independent technology. If you haven't watched that video, that is lecture 1, please go to that video to have a clear understanding of this feature. In today's lecture, we'll discuss other important features of Java which have made Java a popular language, a popular choice among most of the application developers. So the very first feature which we have already discussed, let me state it again, it's Java's platform independency. I'll just revise this important feature, but please go through lecture 1 of this series to have a clear understanding of this feature, because it's very important for anyone learning Java to have a very clear understanding about what is platform independency. We discussed that the word platform means the environment in which an application runs. In other words, it's just the combination of operating system and CPU. Now when you compile a code in C and C++ languages, the compiler generates the platform specific code which is called as machine code. But that machine code cannot be executed on any other platform which is different than the platform on which the code was compiled. Let's say we compile the code on Windows and we are trying to run it on Linux. The Linux platform will outright reject it. Why? Because the way Linux understands the machine instructions is different than the way Windows understands that. So in a C++ application, we have to write the application again, we have to compile it again so that it can run on Linux platform. As far as Java is concerned, this problem is totally solved. In Java, we write our code just once, the compiler compiles it, and then the compiled version, which is called as bytecode, is executed on any platform where there is a special software present called as JVM. To have a clear understanding of this entire concept, please visit lecture 1, go through lecture 1, then where we have discussed this in detail, then you'll have a clear understanding why Java is platform independent. So JVM converts that bytecode to platform specific instruction set and runs it there. So any platform for which a JVM has been made, a JVM is present, can be used to execute a Java application. That is why we also discussed that Java's punchline is VORA, which stands for write once and run anywhere. Write once, run anywhere means programmer has to write the code only one time while he can execute this code on any machine where a JVM is present. This was a short review of what we discussed in lecture 1. So now let's proceed to lecture 2. That is the next important feature of Java. The next very important feature of Java is that Java has automatic memory management. Automatic memory management. Now what does it mean? Let's say while developing a Java application, we require some kind of memory. We all know that normally allocation of memory in languages is divided into two parts. One is called as static allocation. That is, memory allocation process is initiated at compile time. And other one is called as dynamic allocation. That is, the memory allocation process executes at runtime. Whenever we allocate memory dynamically, there is one more thing which we have to do in languages like C and C++, which is that we have to deallocate that memory also. For example, for those who have an understanding of C language, you must be aware that in C, to allocate memory, we used to call a function called as malloc. Or let's say in C++, to allocate memory, we used a keyword called as new. But both these languages taught us that after allocating the memory, after using that memory, we must never forget to release that memory, and to release that memory, to destroy that memory, we used to call a function which was called as free. And if a programmer forgets to call free, we say he is making memory leak, or he is not releasing the memory properly. I mean, any program which makes use of malloc should properly deallocate the memory also by putting a call to free. As far as C++ was concerned, we had a keyword called new, and for deallocating memory, we had another keyword which was called as delete. Once we have called new, we have allocated memory. After we are done with that, we have used that memory for our own purpose. We should deallocate that memory by putting a call to delete keyword. This was one of the compulsions a programmer had to follow, a programmer had to remember. In Java, things have changed for the benefit of the programmer. In Java, while allocating memory dynamically, listen carefully, in Java, while allocating memory dynamically, we have a keyword which is called as new. Okay? But in Java, no memory deallocation needs to be done by the programmer. No memory deallocation needs to be done by the programmer. It's entirely JVM's responsibility that once you are done with this memory allocation process, once you have used this memory block, automatically JVM will deallocate that. We'll discuss this thing in detail when we'll study memory management feature of Java. In short, I'll tell you one thing, that Java has got a very important built-in software routine called as the garbage collector, which is under the control of JVM. And from time to time, JVM executes this garbage collector to deallocate those memory blocks which programmer has allocated, used them, and he is not using it now. So in Java, as a programmer, it's not my responsibility to deallocate memory which I have allocated using the keyword new. While in C and C++ languages, it was a whole soul programmer's job to deallocate the memory also once he has allocated them. Thus in Java, errors like memory leak are very rare, while they were so common in C and C++ if we forget to call free or if we forget to call delete. That is why we say in Java, we have automatic memory management where allocation is done by programmer by putting a call to the keyword new, and its deallocation is entirely handled by JVM using a separate software routine, using a separate process, a separate code you can say, which is called as garbage collector. We'll discuss this in more detail when we learn memory management features of Java in full length. Right now, just a short discussion that memory is automatically managed by JVM. JVM deallocates the memory while allocation is done on programmer's request. That is why to deal with memory errors in Java, we have to write very less amount of code, while in C and C++, there was a huge amount of code need to be written by the programmer. Third point. The third very important feature of Java. Java is one of the most robust languages. Another term to describe this word could be Java is one of the most fault-tolerant languages. Now to understand what is this, let's discuss a very small example in C language. Right? Suppose in C language, we have an array of 5 integers. Okay? And suppose we are iterating over that array, accepting values from the user, but by mistake, we executed the loop 11 times. Arrays of 5 integers only. By mistake, the programmer executed the loop from 0 to 10. That is, the loop iterated 11 times. Let's say we mention the statement enter number, and then while accepting the number, we used scanf and mentioned %d address of ARRI. Now if I ask this question from any C programmer, what would be the output of this code? Just one single word can describe its output, and that word is unpredictable. Anything can happen when the code will run. For example, if there is a space available in RAM, after this much space, this much allocation, the program will run. But say the space is not free, at runtime the code will crash. That is, in C language, there is no checking done by the language that whether programmer is crossing the upper bound of the array or not. The upper bound of this array would be index number 4. But C language puts no check and lets the loop to execute beyond index number 4 also. Now it all depends on runtime situation, that if RAM is free beyond index number 4, the code will run. Otherwise the code will crash. So there can be two answers. That is why I wrote the answer is unpredictable. Now suppose this code is written in Java. In Java also we have arrays. In Java also arrays begin from 0 and they finish at index size -1. But in Java, when the code is executing, JVM keeps a close watch on the behavior of your code. And the moment Java analyzes that you are crossing the upper boundary of the array, Java immediately terminates your code. Java immediately kills your code. In Java's vocabulary, we say Java generates exception. And the moment Java generates exception, the execution of the code is stopped. How good it is? It is good because this behavior of the code is not going to put any ill effect on the underlying system. On the machine where the code is running will have no effect. The code will not disturb the machine's behavior, will not disturb other running programs. While in C and C++, this can cause any kind of havoc. This can cause any kind of runtime error on the machine on which the program is running. In short, the machine on which a Java application is running is safe and secure from any kind of illegal operation which a program can do. Because all the operations which a program performs are first verified by JVM. If JVM thinks these are illegal operations, it immediately terminates your program by generating runtime error, and runtime errors in Java are broadly called as exception. That is why any illegal statement, any illegal code written in Java cannot execute bypassing the JVM, while such codes can be very easily designed in C language and they can run on any system, since there is no check put on your code at runtime by C language. But Java is just like a very strict guardian, very strict parent who always keeps a watch on the execution time of your code, on the execution process of your code, and anything if your code does wrong, Java is there to kill your code, Java is there to terminate your code, saving the underlying system from any kind of illegal access or any kind of harm which your code can cause to that system. That is why we can say that Java is a powerful language, Java is a robust language, Java is a fault-tolerant language. That is why designing viruses or designing such codes which can cause harm to the system is not so easy in Java, while it's very easy in languages like C and C++. So Java is one of the most robust and fault-tolerant languages present on the planet. Right? Fourth feature of Java, which has made Java so popular. Secured. In short, in Java we don't have the concept of pointers. Although we have restricted version of pointers, which is called as references, which we'll discuss when we'll study object-oriented programming. But in a Java language, in a Java program, we don't have such freedom like we had in C language to declare pointers to anything, to access anyone's or anything's address. In fact, in Java, we don't have this address of operator. You just can't use this operator along with variables to get their address printed on the screen. While it is so easy to display anyone's address in C language by simply using the address of operator. People say by withdrawing the support of pointer, Java has become a weaker language as compared to C. But Java says by withdrawing the support of pointers, Java has become a much secured language as compared to C and C++ languages. Because in C and C++, if the biggest strength is pointer, then biggest drawback is also pointers. By learning pointer, anyone can design a malicious program which can cause any kind of harm to the system. They can access hardwares, they can access other programs variables, while in a Java program, it's just not possible to access anyone's address directly because Java totally bans pointer, Java totally bans address of operator. That is why we can say Java is much more secured as compared to C and C++ languages. Security in Java is very strict as compared to C and C++. Fifth feature, which has made Java so popular. Java is a simple language to learn. Now, most of the people do not agree with this feature, right? They say Java is very difficult, Java is very tough to learn. If Java is your very first language, this could be true to a certain extent. But if you are having basic knowledge of C and C++, you can easily learn Java. Why? Because 70% syntax of Java has been borrowed from C and C++ languages. Like in Java also we have functions, but we don't call them functions, we call them methods. They also in Java are identified with parentheses. The opening brace is like this, which indicates that it's the starting of the body of the method. This indicates it's closing of the body of the method. Arrays in Java are also denoted using the very same symbol which you used to write in C and C++. So maximum syntax of arrays, methods, classes in Java has been borrowed from C++ or C language. So if you are having very basic knowledge of C and C++ languages, you can easily go through Java, you can easily learn Java and develop applications in Java. Because most of the syntax part, most of the way of designing the code has been borrowed from these two languages. The only difference is that Java forces object-oriented concepts in everything, while C was a procedure-oriented language. That you will learn later on. But the syntactical part of Java is much more similar to C and C++ languages. So if you are having a basic knowledge of those languages, you can easily go through Java, you can easily learn Java. There is no drawback in that, there is no difficulty in that. Although if it's your first language, you might find some things to be difficult, but if it is your second language after C and C++, Java is very easy to learn. So it's truly said that Java is one of the most simple languages to learn. Next feature. Java is an object-oriented language. Java follows almost every concept we have been taught in object-oriented programming. For example, in a Java program, it's very essential to make use of class. To write a very simple application like Hello World, you have to make use of class. And if you are aware with basic principles of OOPS, you must understand that writing a class for everything is something which is called as encapsulation. So Java truly supports the concept of encapsulation. We just can't declare an integer beyond the boundaries of a class. Everything we write in a Java program has to be a part of the class. So features like encapsulation, features like inheritance, features like polymorphism, features like abstraction can very easily be demonstrated and learnt in Java because they all are building blocks of a programming paradigm which is called as object-oriented programming. So by learning object-oriented concepts, if you want to implement them in Java, you can easily choose Java as an implementation language because it supports the concept of encapsulation, it supports inheritance, it supports polymorphism, abstraction. Almost every feature learnt in object-oriented programming is supported by Java, right? Some people say Java supports variables. That is why Java is not a pure object-oriented language. But Java internally converts these variables into classes and objects. That is why we can say Java is almost pure object-oriented language since it provides us the facility to either use variables or convert these variables into objects. In later lectures, we'll learn something about very important classes in Java called as wrapper classes, which allow us to convert a variable into an object. That is why we can say Java is one of the most object-oriented, strictly following object-oriented concepts language. Next feature. Java has very strong support for a very important programming principle which is called as multi-threading. Now what is multi-threading? To understand this feature, let's have a basic example of a very simple C language or C++ language code. Let's say we have a C language program in which we are calling, let's say, 3 functions. One of them is, say, factorial. Okay, I'm passing the number 5 and let's assume this function is going to calculate factorial of 5. I'm having another function which is totally independent of factorial called as prime. I'll pass the number 10 to this function and it will check whether the number 10 is prime or not. And let's say I'm also having a function called even odd. I'll pass 7 to this function and it is going to check whether 7 is an even number or odd number. I repeat, I've got 3 functions in my code. One is factorial, other one is prime, third one is even odd. Now as you can see, all these 3 functions are independent of each other. None of them have to have anything to do with the other two functions. Like factorial can run independently of prime. Prime can run independently of even odd. But the way they execute in C language, the program execution starts from main. Then main will call factorial. The entire focus of CPU will go towards running the factorial function. And until and unless execution of factorial is over, the control will never come back to main, and prime and even odd will never get a chance to run. Java is against this concept. Java says if they are independent of each other, they can run in parallel. That is, they can run together. And this is what is called as multi-threading. That is, by the time we have called factorial and factorial code is running, in the mid of that code, we can call prime. And during the execution of prime, we can call even odd. In short, multi-threading means making multiple functions or multiple methods of the same program run parallelly. If multiple methods of the same application are executing parallelly, we say that the application is using multi-threading. What are the benefits of that? The most important benefit is CPU's idle time is utilized. For example, let's say we are not passing 5 to factorial. The function factorial will accept the number from the user. We all know that while accepting user input, most of the time CPU sits idle. During IO operation, CPU sits idle. And it is this idle time which multi-threading can smartly utilize by switching over the CPU to calculate prime or to calculate even odd. That is the major benefit of multi-threading. Another benefit, the speed or the execution time is reduced, the speed is increased. This all we'll discuss in detail when we learn multi-threading. It's a big chapter. It will have various lectures to understand internal concept. But in short, in a Java application, it is possible for a programmer to execute multiple methods in parallel. Another benefit, you can say, the program becomes much more responsive. How come? Let's say in factorial function, due to programmer's mistake, the loop executed infinitely. Now in a C program, if factorial runs infinite, the entire application will hang. The control will never come back to main, and prime and even odd will never get a chance to run. In Java, even if it is running infinitely, there are chances that prime and even odd will run because all three of them can run in parallel. So in a Java application, by using multi-threading, we can make our applications more responsive. Web browsers, media players, gaming applications, they all make use of concept of multi-threading because if you closely observe them, in all these softwares, there are various activities which are taking place parallelly. And this is the feature of multi-threading, right? Then, another very technical and important feature, Java is a distributed language. Now, what is distributed? Try to understand this again with a simple example. Let's suppose in a C language program, I mentioned the statement hash include stdio.h, and inside my main method, let's suppose I mention the statement printf. Now we all know that the code for printf is written in some library file available in your C language software. Now suppose that library file is corrupted. Suppose that library file is missing. So when this program will execute, at runtime, it will throw a linker error if it is not able to find the definition of the function printf. Suppose this very same code was written in Java, and on a network this program is running. Let's say this program is running on a particular computer which is connected to another computer on the same network. Let's say on this computer where the code is running, the library file of printf is missing, but it is available on some other computer. So in Java, using distributed programming concept, we can call a method lying on one machine from another method lying on another machine. Like we can design main on machine 1. Main can call a method, the body of that method might lie on machine 2. But if these two are connected with a network, we can call method 2 of machine 2 from method 1 or main of machine 1. That is, the method body is lying on some other machine, the call to the method is being given from some other machine, and they will behave as if they are lying on a single machine. This feature is very, very important when we develop applications in Java, because if in our project we have 4 programmers working, all 4 of them need not be present physically on the same machine. They can sit on their own machines. All the machines can be connected with the help of internet or any kind of network, And any class, any method running on one machine can be accessed from a program running on other machine, provided both the machines have JVMs present so that one JVM can communicate with other JVM. In Java, this feature is basically called as RMI. The full form of RMI is R for remote, M for method, I for invocation. Remote means method is not available locally. That is, method is not available on the machine from where it is being called. Invocation is call to the method, and method is the block of code or the body of the code, right? So by writing a code on X machine, we can call it from Y machine, and this is called remote method invocation, which is very useful feature when we have programmers working on different machines, but they are working on the same project. Their machines can connect logically, and a programmer can write a class on one machine, and another programmer can create its object or call its method by sitting on another machine. This is called distributed computing. In Java, it is achieved using the concept of remote method invocation. These are some very important and useful features. There are not many other also, which we'll be discussing in the forthcoming lectures. But these are main features which everyone should know before beginning programming with Java. I hope you enjoyed this lecture and learned a lot of new things from this lecture. I'll see you in lecture 3, where we'll be discussing history of Java and some other features of Java. Thank you.